In this video, we're going to look at the Chapter 10, Section 3 slides and solve the problems involved there. We're starting here evaluating these permutations. Remember that NPR is equal to n factorial over n minus r factorial. So 4 pick 2 is given by 4 factorial over 4 minus 2 factorial, or 4 factorial is 24, divided by 4 minus 2 is 2, 2 factorial is 2, so that's 12. 8 pick 5 is 8 factorial over 8 minus 5 factorial. Okay, so that's 40,320 divided by 8 minus 5 is 3 factorial, which is 6. Plug that into a calculator, and we get 6,720. Finally, we've got 5 pick 5. So that's 5 factorial divided by 5 minus 5 factorial. Okay, so 5 factorial is 120 divided by 0 factorial, which is 1. That gives us 120. Now we've got some more complicated permutations here. 10 pick 6 is 10 factorial over 10 minus 6 factorial is 4 factorial. Okay, well, I can do this. Makes it a little simpler for us. That's 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial leaves us with that 10 times 9 times 8 times 7 times 6 times 5. And again, I'll plug that into the calculator. 10 times 9 times 8 times 7 times 6 times 5 gives us 151,200. 28 pick 0 is going to be 28 factorial over 28 minus 0 factorial. It's 28 factorial over 28 factorial, which is 1. Finally, we've got 18 factorial, 18 pick 12, which is 18 factorial over 18 minus 12 factorial, which gives us 18 factorial over 6 factorial. Okay, well, that's 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 9 times 8 times 7. And then we'd have a 6 factorial, and that would cancel with the 6 factorial down here, and that's going to be a big number. That's 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7. That gives us 8,892,185,702,400. Big number. How many non-repeating 3-digit numbers can be written using only the digits 3, 4, 5, 6, 7, and 8? All right, now none of these numbers is a 0, so we don't have to worry about that. What we need to do is say we've got 1, 2, 3, 4, 5, 6 values, and we're going to pick 3 of them, and order matters. So that's 6 factorial divided by 6 minus 3 factorial, or 6 factorial over 3 factorial, which is 720 divided by 6, or 120. Certain account numbers are to consist of 2 letters followed by 4 digits and then 3 more letters. Repetitions of letters or digits are not allowed within any of the 3 groups, but the last group may contain the letters used in the first group. How many such accounts are possible? Well, first we're going to figure out the value, the number in the first set. We've got 26 letters times 25 letters after we pick the first one times 24 letters after we pick the second one. Then 4 digits, that's 10 times 9 times 8 times 7 times 3 more letters would be, this is supposed to be 2 letters up here, so we'll just do the 2 letters here. 26 times 25. Still going to be a pretty big number. Now they do this a little differently because we have to pick different numbers. That's what's going on there. So I'm doing this a little wrong. I apologize. This should be 26 pick 2 times 10 pick 4 times 26 pick 3. Okay, that's going to be a little bit easier. This becomes 26 factorial over 26 minus 2 is 24 factorial times 10 factorial over 10 minus 4 is 6 factorial times 26 factorial over 26 minus 3 is 23 factorial. Okay, well, that becomes 26 times 25 times, we'll put this in parentheses, 10 times 9 times 8 times 7 times 26 times 25 times 24. Which is 650 times 5,040 times 15,600. Multiply these numbers together, we get 5,110,560,000. Here we are asked to list the subsets of n equals A, B, C, D, E that contain 3 members. And we want to know how many there are. Well, we can start by listing A, B, C. And then A, B, D, and A, B, E. Then we've got A, C, D, and A, C, E, and A, D, E. And that accounts for all of the subsets that include an A. So then we move on and we take B, C, D, and B, D, E, and B, C, E. And then we've only got one more, which is C, D, E. And now we've accounted for all 10 subsets of A, B, C, D, E that have 3 members. Okay, evaluate each combination here. Now, combinations have a different formula from permutations. The formula for n choose R is n factorial divided by n minus r factorial times r factorial. And this is because in combinations, the order matters, and in combinations, the order doesn't matter. In permutations, order does matter. So this is 9 choose 7. So that's 9 factorial over 9 minus 7 factorial times 7 factorial. Okay, well, that's 9 times 8 over 2 factorial, or 2, which is 9 times 4, or 36. If we were taking permutations, this would be 9 factorial over 2, but we're taking combinations and we get a lot fewer. 24 choose 18 is 24 factorial over 24 minus 18 factorial times 18 factorial. Okay, well, that gives us 24 times 23 times 22 times 21 times 20 times 19 times 18 factorial over 24 minus 18 is 6, so that's 6 factorial times 18 factorial. Okay, well, I can cancel those, and then I can expand this. 6 times 5 times 4 times 3 times 2 times 1. I'm not going to bother writing the 1 because we know that that anything times 1 is itself. Well, 6 times 4 is 24. I can get rid of that. There is a 5 in 20, which leaves us with a 4, and then there's also a 2, so we can just turn that into a 2. And then there's a 3 in a 21. So this becomes 23 times 22 times 7 times 2 times 19. Which is 134,596. 14 choose 6 is 14 factorial over 6 factorial. 14 minus 6 factorial times 6 factorial, which is 14 factorial over 8 factorial times 6 factorial. So we can say that this is 14 times 13 times 12 times 11 times 9 times 10 times 9 times 8 factorial over 8 factorial times 6 times 5 times 4 times 3 times 2. Cancel those. 6 times, let's do 5 times 2 is 10. 6 goes sorry, my brain is not quite functioning today. 4 times 3 is 12. Yes, this is better. And then we can take a 3 from 9 and a 2 from 14 to get that 6. And now we've got 7 times 13 times 11 times 3 is 3003. Finally, 23 choose 15. 23 factorial divided by 23 minus 15 factorial times 15 factorial. Okay, well, that's 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 times 15 factorial over 15 factorial, right there, times 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2. Okay, our 15 factorials go away. 8 times 2 is 16. We've got a 3 in, we got 3 times 7 is 21. We've got a 5 in our 20 and also a 4, so we can get rid of that. And we've got a 6 in our 18. There we go. We're left with 23 times 22 times 19 times 18, no, times 3 times 17. Let me do that once more because I think I entered something wrong. 23 times 22 times 19 times 3 times 17. That's better. That is 490,314. A common form of poker involves hands of 5 cards, each dealt from a deck of 52 different cards. How many different 5-card hands are possible? Well, here, this is just as simple as 52, choose 5. Okay, well, 52 choose 5 is 52 factorial over 52 minus 5 is 47 factorial times 5 factorial. Okay, well, that's 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 times factorial times 5 times 4 times 3 times 2. I'll get rid of my 5 and my 2 from 50, which brings us down to a 5 there. We'll get rid of a 4 from 52, which gives us a 13, and a 3 from 51, which leaves 17. Now we have 13 times 17 times 5 times 49 times 48, which is 2,598,960 hands. Carrie would like to buy 10 different paintings but can afford only 4 of them. In how many ways can she make her selections? Well, this is a case of 10 choose 4. Okay, so that's 10 factorial over 10 minus 4 is 6 factorial times 4 factorial, which is 10 times 9 times 8 times 7 over 4 times 3 times 2. We won't bother with the 1. 4 times 2 is 8. 3 goes into 9. We're left with 10 times 3 times 7 is 210 ways. In how many ways can a mother distribute 3 different toys among her 7 children? The child may receive anywhere from none to all 3 toys, and there are anywhere from none to 7 of each toy. Now, this is not a factorial, is not the same kind of problem. This is a case where we can give any of 3 toys to each of 7 children. So that's 7 possibilities for the first toy times 7 possibilities for the second toy times 7 possibilities for the third toy, which is 243 total possibilities. Is that right? No, 343 total possibilities. Sorry about that. How many different 3-member committees could Club N appoint so that exactly one woman is on the committee? Remember, Club N was the set of Alan, Bill, Kathy, David, and Evelyn. So we want to appoint exactly one woman to the committee. That means we have to choose one of Kathy and Evelyn, 2 possibilities there, and then 2 of Bill, of Alan, Bill, and David. So that's 3 choose 2. This is actually 2 choose 1, but that's the same thing as just 2. So that's 2 times 3 choose 2 is 3 factorial over 1 factorial times 2 factorial. Okay, well, 1 factorial is just 1, but that's 3 factorial over 2 factorial, which is 3. So 2 times 3 is 6 ways. Or in this case, 6 committees. Every member of the Alpha Beta Gamma Frat would like to attend a special event this weekend, but only 10 members of the will be allowed to attend. How many ways can the lucky 10 be selected if there are a total of 48 members? Well, here we are doing a combination problem. This is 48, choose 10. Order doesn't matter. So that's 48 factorial over 48 minus 10 is 38 factorial times 10 factorial. Okay, so that's 48 times 47 times 46 times 45 times 44 times 43 times 42 times 41 times 40 times 39 over 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And again, don't bother with the 1. 8 times 6 is 48. 9 times 5 is 45. 10 times 4 is 40. 7 times 3 times 2 is 42. That leaves us with 47 times 46 times 44 times 43 times 41 times 39. Multiplying those together, we get 6,540,715,896. Lots of possibilities, and only one gets you and your 9 friends in. When the 10 fraternity men arrive at the event, 4 of them are selected to pair with 4 homecoming queen candidates to escort them. In how many ways can this selection be made? In this case, order matters because there are 4 different homecoming queen candidates. So in this case, we do 10 pick 4. Okay, well, that's 10 factorial over 10 minus 4 is 6 factorial. And that becomes 10 times 9 times 8 times 7. Which is 5,040. Last page here. In how many ways can the 9 members of a baseball lineup divide into groups of 4, 3, and 2 players? Well, if we pick first the group of 4 players, and again, order doesn't matter, so we're going to do a combination here. That's a 9 pick 4, or 9 choose 4 rather, And then we are left with 5 players, and we pick 3 of them, or choose 3 of them. And then we're left with 2 players. And there's only one way to arrange those 2 players. Okay, so that gives us 9 choose 4, which is 126, times 5 choose 3, which is 10, or 1,260 ways. And how many ways can the 9 players be divided into 3 groups of 3? Well, in this case, because we can order these groups in multiple ways, things are a little bit different. This is going to be not, as we might think, 9 choose 3 times 6 choose 3 times 3 choose 3, but 9 choose 3 times 6 choose 3 times 3 choose 3 divided by 3 factorial, which is 6. Okay, well, that is, the numerator here is 1,680 divided by 6 gives us 280. That's it for this video. If you have any questions, please get in touch.